And the first question is, what is your primary discipline? Getting some responses now. Looks like we have some petroleum engineers in the audience. Okay, the first question is, what is your primary discipline? So responses are between petroleum engineers, geoscientists, facility engineers, petrophysicists, or other. So far, it looks like most of you have voted and all are 100% petroleum engineers. So I'm going to share those results and then we'll go on to our next polling question. And the next question is, how many years of full-time experience do you have in the upstream oil and gas industry? So we're starting to get some responses. Some of you are in the 1 to 10 year range. Some are 11 to 20 years. So you have some mid-career professionals in this group. Responses are still coming in. And it looks like most of you have voted, so I'll go ahead and close and share the response. It looks like everyone's in the mid-career range between 1 and 20 years. So before I introduce Dr. Shochki, I'd like to remind the audience that you're muted, but you can ask questions during the webinar using the GoToWebinar question feature, and we'll cover the Q&A at the end of the presentation. You will be anonymous. So I have some slides to share. And again, the presentation today is called Production Data Needs TLC 2. And the webinar will begin shortly. Our presenter today is Dr. Rajan Shochki. And Dr. Shochki has over 35 years of experience in artificial lift, real-time production optimization, software development, and management. And he teaches a course on data analytics workflows for artificial lift production facility engineers, as well as several other courses related to artificial lift, gas lift, producing unconventional reservoirs. We have a number of free webinars that are coming up in August and September. Live online courses are happening in July with Dr. Nathan Meehan and Dr. John Lee. And in October, we have Dr. Larry Lake and Dr. Jerry Jensen teaching live online courses as well. Courses can be taught in-house as private courses. You can attend public courses in our office or, of course, live online. And in addition to training, we offer consulting and recruitment services. And so now I'm going to give the presentation rights over to Dr. Shochki. Let's see. There. You should have the presentation.
Yes.
And we see your screen.
Okay. All right. Good morning, good afternoon, good day. Thanks for attending this webinar. When I say production data needs TLC2, what I mean is throughout my career, I have worked on some of the challenging design analysis problems, and in most of the cases, or in many cases, I should say, what I realized after the fact, and being a slow learner that I am, I realized that if sufficient attention is not paid in the beginning of any such effort, whether it's a design or analysis, real time or otherwise, if you do not pay sufficient attention to the data set, then you are either going to make some costly mistake or you will have to revisit that topic. So if we pay attention to this at the beginning of any project, then we save ourselves lots of challenges. Now, what I'm going to present today is from the class that Susan mentioned just a bit ago. Now, in the class, of course, we talk about most of the time analytics using the real data sets, but we also touch upon the same topic that I'm going to discuss over the next 30 to 45 minutes or so. I have, as I said, I have learned this over my 35 plus years of practice, but last 5 or 6 years, when I started focusing more on the real-time data sets, the today's theme became more and more important. So what I'm going to present today is starting with digital transformation, just so that we are all on the same field. I'll mention some of the key technologies that are enabler for the digital oil field, some sensing technologies as well as analysis. And then we'll go right into the topic of the day, which is what are the data types, what are the challenges, where are the opportunities, and I'll discuss a few case studies. Now in the class, of course, we go beyond this, meaning we bring in the data, I show how you can identify some of the challenges with the data and what you can do about it, right? Before you perform any of the fancy analysis, whether you're doing a simple linear regression in Excel or you're using Python or R or whatever is your preferred medium, language media is. But still, what we are going to discuss today remains valid. So regardless of the sophistication of the tool sets, frameworks, or the methodologies, if you do not take care of some of the basics, then you will not achieve the desired objectives. And many projects I have seen are not as successful or in worst cases fail because of not paying sufficient attention. Most of the experts in the field, not only in petroleum engineering but outside, also agree that oftentimes we spend more than 40 to 60% of the time just dealing with the data, cleaning it, making sure that it lines up with the ultimate objectives or not. And in that context, I'm saying that the production data also needs TLC, tender loving care, in case you didn't know that acronym. So when you open up any of the JPT issue or other trade magazine, you'll come across this digital transformation theme being repeated, where people are saying that how we'll use the digital transformation to transform our business. But what we need to keep in mind is that you can only transform a business by applying the high quality data, okay? Now, digital transformation has been talked about since forever, I would say. But beginning early part of this century, we started seeing some pronouncement like this, that companies came out and said that, we are saving 25% or we're saving 10% or whatever. And over the time period, we moved from production optimization to digital oil field, and now we talk about digital transformation. But the idea is the same, that how we can use some of this data convert it into information so that we can make some informed decisions. There are companies also, there are a couple of, like from 2019, this highlights came up that how BP is claiming billions and Southeast Asian operators are also digitalizing. So if we step back and ask the people in the field, whatever is your role, what are the problems that we are facing? Whether you're a field operator or production engineer, reservoir engineer, pipeline engineer, process engineer, or the asset manager, right? Each of us have our laundry list of questions that are always at the top of our mind as we report for the duty. Am I meeting my targets? Are my wells running? But if you have to summarize all of them, then they can be, is everything delivering per the plan? Are there any hurdles or problems that I need to prepare and plan for? Are there any failures that can derail my plan, right? Do I need to prepare for those failures? If I cannot prevent them, at least can I prepare for them? And how I can improve my profitability? What are the factors? Okay, people focus, of course, on the production forecast, the installation and the activities that are causing production deferrals. And very, very important, the safety of the people, safety of the environment. And initially, when you are starting on this journey, you're thinking in terms of single time effort, meaning, okay, let me take care of this problem now. But as you keep on seeing the same issues occurring again and again, you realize that you have to basically put some sustained practices. So let's go back to what are the digital oil field approaches, right? So it always starts with some sensing, meaning capturing the data, right? And there are a variety of data, pressure, temperature, on and on. There is a long, like list of items, but most of them relate to some kind of measurement that tells us about health of the system as an overall or a particular component of the system. So if either of them fail, then our production gets deferred, right? So that's why we invest a lot of money. We, meaning operators, invest a lot of money in sensing equipment, right? Next comes, okay, just by sensing, it doesn't do as much. So we need to have some kind of communication, computation, control side of it. And that is another big part of it as things move more and more towards cloud, even if it's a private cloud. So plus we need to store the things, we need to apply some computations. So this is what I call communicate, compute, and control layer after the sense layer. And finally comes the collaborate layer, where the subject matter experts like ourselves work with IT folks, data scientists, data analysts to make sense of all this data torrents or data trickle, depending upon where we are in our maturity. We try to make sense of this data, right? And of course, business people, they would always ask the question that, hey, I have invested so much in this equipment, in this technology. Am I getting my returns or not? So we have to pay attention to some of the data. That's what I'm trying to say here. Now, how do companies proceed in this digital oil field progression? As at a basic, as I said, you need to have some kind of sensing, surveillance, monitoring, and diagnostic. Then comes the analysis side of it, where you try to understand, hopefully in real time, what is going on. Then you basically perform some sort of optimization, and that hopefully would happen in real time, and finally comes the innovation. I can see that there is some color that is missing here, meaning some of the text here has become white on white. My apologies for that. I'm not going to interrupt, but what those text items say that for surveillance and monitoring, we need to have some kind of sensors, we need to have some kind of SCADA system, etc. when it comes to analysis or understanding in real time is where you put some sort of additional computations on top of this SCADA system. Now, those computations could be physics-based computation, um, and then if you have some controls in the field, then remotely you actuate those controls so that you can change the flow rates, you can change some control valves so that you can, or you can even stop some machinery in real time so that further damage doesn't happen, or so on. And when we talk about innovation, AI and machine learning, the idea is automation. So some of these actions that happen sequentially, which require some human input, can occur rather speedily. So an example could be that if a control room operator is sensing that something is going outside of high range, then he or she takes appropriate action to open something or close something, right? Or to alert. So how we can train some of these models so that they can start performing that action. Now, the intent is not the demanding in this. Of course, that's a real concern for the people, but the intent here is to kind of respond quickly so that the further deterioration doesn't happen, whether it's a condition of the equipment, condition of the process, which can lead to some production deferral, or it could be some very damaging event like environmental release of hydrocarbon, etc. Okay. So further moving on, now we'll talk about data types and variety now that we have seen the digital welfare side of it. So as the Lord Calvin famously said, if you cannot measure it, then you cannot improve it. So let's look at what type of data that we typically measure and what is the variety of data for in the production and facilities management. So here I'm going to refer to this graphic from Saeed Mubarak that very well finds out that data loops are typically very fast in the production. And so in the drilling also, because the processes are happening relatively fast, and sometimes you have to make decisions also very quickly. So oftentimes we will say that, yeah, we are very tactical. Whereas if you're looking at the reservoir simulation or modeling, then your time horizons are much longer. Of course, you are going to rely on the data provided by some of these processes here, but still your horizon is longer. So you have slightly longer reaction time. So takeaway is that the data loops are very fast for production folks, and that's where some of the analytic techniques that I talk about in the class are very, very important. Because if your data loops are fast and if your decision loops are slow, then those faster data loops cannot do you much. And you might defer your production for much longer than what you would. So again, I bring back the same graphic that we saw a few slides back, that we have to keep in mind where from the data is coming. And as I showed here, that there is a field instrumentation that provides pressure, temperature, differentials, load, position, etc. So with that, there are some other data that we are capturing increasingly from inside the wellbore or closer to the reservoir. But that, because keep in mind, at the end of the day, if we are focused on the health of the well or health of the reservoir, then it is best that we capture some data inside the wellbore closer to the reservoir. And that's where this permanent downhole electronic or quartz gauges come into picture. They can pump out the data at very, very fast frequency, whether it's pressure, temperature, or vibration. And newer generation, more expensive fiber optics technology, well, I shouldn't say newer generation, it has been around since last century or even longer. But it is gaining more and more traction. And here you are not only sensing at a point using fiber optics technology, but you're sensing along the entire wellbore. So the examples are distributed temperature sensing, distributed acoustic sensing, and such. You can also have multiple gauges, as I've shown by these red dots on here. So net sum of all of this is that as a production engineer, you have a lot more data coming at you at much higher frequency and much wider variety. We are not in the space where we used to rely on receiving some charts from the field, the circular chart that gives us some kind of pressure temperature measurements. Now we are able to see the data with very, very small latency coming at us. Another important part of the infrastructure is compute, control, and communicate. That's where we have some sort of control mechanism at the well side comes in, whether you call them controllers, variable frequency drives, data loggers, and increasingly now people are talking about edge devices. And what these devices do is that they not only monitor the equipment that are connected to it, I mean the sensing equipment, sensors that are connected to it, but they also can make some small degree of autonomous decision, meaning based on some measurement. For example, if it's a tank level measurement connected to this controller, and if it senses that tanks are reaching the critical level, then it can stop the pump. Or if the liquid level is below a certain level, then it can start the pump. So there are quite a few variety of actions that can be performed by these controllers, and they are becoming very, very sophisticated. For example, variable frequency drives, they can vary the speed of a rod pump throughout a stroke. Uh, as I mentioned earlier, edge devices is kind of souped up controller in my mind, meaning you have a lot more computational capabilities on board. It can also perform some of the AI type of model calculations. It can sample the data at much higher frequency and perform the computation. So they are preferred more and more as you progress in your journey towards the machine learning and AI-based implementation. Now let's look at some of the data types. So here, starting from the top right corner, we are looking at some traces coming from the electrical submersible pump, or ESPs. ESPs were traditionally the most instrumented artificial lift system when they started. So you have variety of pressure, temperature, current frequency, voltage measurements available. And because of the expensive nature of the equipment, people would like to focus more on how my ESP is doing. Is it going to fail or not? And there are some sophisticated models that we'll talk about later on in this presentation. Same goes for gas lift. As it is becoming more and more prevalent, particularly in the unconventional space, we are sensing not only injection, gas lift injection rate, but also downhole pressure, temperature values and such. Plunger lift, ditto, and rod lift has been also instrumented traditionally in the form of surface load and displacement, but now we are coupling that with not only the wellhead pressures, temperatures, but also down. So what your takeaway should be is that, yeah, we have a variety of real-time point measurements coming depending upon the number of sensors deployed, sophistication of the SCADA system, sophistication of the control mechanism, right? As I mentioned earlier, distributed temperature sensing and distributed acoustic sensing, that is possible with the fiber optics type of systems, allow us to capture data at a lot higher volumes. And this has, as I say, this has been done for a long, long time. For example, here is this paper from 2007 gas lift workshop where people were talking about using the distributed temperature sensing data to diagnose slugging gas lift well. And here is a relatively recent example of how somebody used this acoustic sensing data plus temperature sensing data to figure out whether there is any gas lift valve or the packer leak in a well in the North Sea. So one thing we have to keep in mind is that the amount and the variety of data that you have to process here, it makes it imperative that you cannot perform any manual calculations for this. You have to have some sort of sophisticated infrastructure to perform some of these calculations. Okay. Now, other than real-time data, we also have to have some discretized data, like production measurements, injection measurement, completion data, what type of jewelry do we have, reservoir data, pressure, temperature, reservoir productivity index, PVT data, what type of well activities have been performed, whether well was worked over or somebody changed the injection rate when, and if ESP was changed, when it was changed, to what it was changed. So all of this information is equally important for performing some of this analysis. Now, it is possible that you can do without this type of data if you go for pure real-time data-driven approach, meaning do not take into, but increasingly what we are finding is that pure data-driven approaches based on just real-time data rarely succeed. You always have to infuse it with some sort of physics-based approaches, what is called hybrid approach, meaning when you come up with some feature set, if you take into account some of the wells features, chipping size, for example, or I'm just throwing something, or location of the gas lift valve, then those models tend to perform better. Okay, so if I have to give you one slide, this one slide gives you a laundry list of all the data that you typically need in order to solve production related challenges, whether it's an artificial lift or even naturally flowing well or injection well. You require not all of this, but a subset of this. If you have all of this, then you can perform much richer analysis. But if you have a subset of it, then you can perform some limited set of analysis, right? Now, with the data also comes the data processing challenges. And as this graphic on the left shows, that oftentimes we move around with a cloud hanging over us because we know that the bad data is out there, but what we don't know is that how it is hurting our decision making, meaning how it is hurting our analysis. All the ways bad data is holding you back. And that's why I said that the production data needs TLC too. If we start paying attention to our data, whether it's inconsistent, whether it's incomplete, ambiguous, or just plain wrong, if we do not know that and if we just pass it on to very, very smart data science people, and if they run with it, we might end up getting some wrong decision points. And that's why it is our job. So let's recount how our data can have problem. And there's nothing new here what I'm mentioning, but it is worth keeping in mind that oftentimes data is not always what it seems. We need a validation layer. Many times we have found that we do not have key measurements. Sometimes flow rate may be missing, some pressure may be missing. Measurements may not coordinate, meaning upstream pressure may be much, much smaller than downstream pressure, or they may not correspond to a physical model. We may have some negative values for pressure measurement, or we may have flat line data. We may have some discontinuities. We may have some repeated values, again, frozen data set, what is called, right? And there may be many, many reasons for this quality and quantity issues. Most of it, many times I heard this, that we do not have enough data because our field infrastructure is wrong. If you have analog instrumentation like this, then it becomes very challenging, right? Meaning companies have to invest on some newer sensors. Communication used to be a challenge. Increasingly now, most of the globe is covered with the satellite, or increasingly the GSM, cellular signals. So that problem is becoming less frequent. And then the legacy data, especially if you have brownfield asset, then you have lots of old data and trying to line up different data sets becomes a bigger part of the challenge, right? Some information may be missing. All of a sudden, your WiMAX goes out of whack, and then you lost the signal, right? Or you may have some malfunctioning measurement device because calibration was not performed. And oftentimes we have seen that somebody says that we have X model of ESP in the hole, or the depth is this, until the equipment is pulled out of the hole because of failure, and we find out that no, all along we had something. Now, again, these things do happen, thankfully not that frequently, but we have to keep this in mind. Another major issue, and this is more on the data management side, as I work with some of the technology companies, I'm beginning to see this more clearly, that as companies rush towards building up the data lakes, what they find is that there are different groups within the same company, and they all handle the data set, but they may have multiple copies of the data set. One copy may not be the most current, etc. Um, and as a result of that, what happens is that the analysis may not be complete, or it may have to be reperformed if later on we find out that the data was incomplete or not correct. And that's where companies are performing lots of data integration work. Now, this is not our meaning production engineer or petroleum engineer's duty, but it is our duty to make sure and to help the IT folks identify such inconsistency. By the way, this graphic is courtesy of ConocoPhillips, Canada. There is a notation at the bottom, but somehow the color scheme has obscured that. Okay, another one, when I talk about the data processing side of it, then the ingestion, meaning how do you bring that data into whatever framework that you're using? There may be field reports that may have some pictures or videos. What do you do with those things? There may be some analog paper charts. How do you digitize them? And then there's a lot of what I call tribal knowledge that goes in text messages. I see even WhatsApp messages. Of course, email, we use it to report status of the field or equipment or whatever. Now, how do you bring in all of that information? How do we, and that is where companies are really spending a lot more effort, in my opinion. And there are some interesting things happening on the process side of it. But still, this is a challenge, especially if you do not have access to such sophisticated processes, because this data is difficult to what is called vectorize, meaning you cannot perform this data science techniques. You cannot extract the metadata. Metadata is the information about data itself. Like if you have a series of numbers, what does those number belong to? Is it, well, XYZ equipment ABC or what? So there are lots of challenges with such unstructured data, and that we have to keep in mind. There are some industry efforts on standardization, data formatting, representation, etc., etc. There is Energistics has been working on it on WITS-ML, ProdML, and now we are using more OSDU, supposedly technology agnostic data platform that quite a few companies have subscribed to. But I still continue to see in my practice that even within a company, there is a lack of standardization. So these are all the challenges that we have to keep in mind if you are going to lead any such data analytics project or not. So now where are the opportunities? So let me talk about some of the cases. Now there have been many, many more that have been deployed. People do not talk about it. I'm just talking about the ones that I have come across. But oftentimes people ask me when I conduct this class is that, okay, Rajan, give me use cases. Use cases meaning where can I use what you're teaching me? Show me some examples. And in my mind, whenever you have any measurement, and if you can visualize what is the physical process where from that measurement is coming, then you can use those set of measurements to if not improve the process, at least understand the process better, right? And that is what I mean when I say that the possibilities are endless. Because earlier it used to be that, okay, we have this data stream coming to us and I don't have tool sets. I have to plug it into Excel and then write this macro to perform it. Nowadays, it has become so easy with some of the Python and R and those type of approaches. And I'll mention later on some of the generative AI tool sets. There are no code or low code platforms that are being developed. That makes it very, very easy to analyze the data, to visualize the data and such. Your options are not just limited to Excel and Spotfire or whatever is your tool of choice. If you are willing to pair up with some smart programmer or dirty your own fingernails, then it is very easy to deploy some of this. Compute power is also very easy. So now let me talk about some of the examples. So here what we are looking at is a simple Power BI visualization. In the bottom, and as you can see, this is for hundreds of wells in an asset. So you select any well, and all of a sudden, at a glance, you see what was last couple of years measurement for that ESP, and you can zoom in, zoom out. But more importantly, the data that is not in the real-time data stream can be also brought in, whether there was a change in the configuration, ESP was changed, whether there was some acidization performed, or there was a failure of the ESP, all of that information. So when you start pairing up like this, and then you prepare a feature set, then it really makes the analysis very easy. So this timeline visualization is very powerful. It helps you isolate the activity or group of activities that contribute to either uplift or deterioration of well's health. Okay. You can also use this to identify the need for scheduling or deferring a remediation measure, right? Are we conducting too many hot oiling? Or should we move a well to a wet header? These are some of the questions that can be answered with this type of. Now let me share with you an example with one paper that I co-authored with Luis Gonzalez several years ago, I think around 2015-16 timeframe. We were looking at some data set from Permian wells, condensate well, gas lift visualization. And here are some Signet screens. You can see this 2015 data set. And you can see, of course, that there are some changes in the injection rate and the downhole gauges and everybody. But what we saw more clearly when we saw the downhole gauges and zoomed in is the slugging. And this slugging often is result of the long lateral that we have, right? So until that point, the only slugging you would see is at the surface muted. But the moment you see this, there are some possibilities. But we were not focused on just visualization. Where we focused on was it that how we can use this data to come up with some predictive calculations related to the reservoir parameters like productivity index and static bottom hole pressure. So we use this Minitab software and we kind of combined it with the nodal analysis approach. And you can refer to this paper if you're interested in understanding this further. But the bottom line was that just using data measurement like this, we came back with almost quasi real time calculation of static bottom hole pressure and PI, right? Which is very, very powerful because in case of unconventional wells, as you can visualize, the productivity drops very fast. Here is another example, and you're seeing, looking at on the right side, about a couple of hundred lines of Python code that I have written, and I'm not the best programmer, right? Just to perform the analysis for about 7 months worth of the data, right? And in this particular case, the operator was able to measure the data every day. And then trying to come up with, and this is the downhole gauge measurements, right? We were trying to come up with, okay, how the reservoir pressures are changing and how the IPR is changing. So I'm just showing you some preliminary results. Of course, the final results were much more detailed. But my point being that when you have such rich data set coming to you, now we have at our disposal the tool sets to analyze them. We do not have to just go back to our favorite nodal program or to plug it into some Excel. Okay, nothing against either of those approaches. What I'm trying to say is that when you have such a high volume and high frequency of the data set, then having such tool set is important. This problem, which is the ESP failure prediction, has been tackled by multiple teams because of production deferral issues, ESP being high volume, high value wells. And what when you look at these three papers that have been published in the last few years, and there are a few more that I might have missed, what you'll come up with is that there is some static data set that, static data set that everybody starts with. And then, of course, they look at dynamic data, and then some of them come up with calculated features based on this dynamic and static data, and they apply it differently. So if this is something that is of interest to you, I would recommend maybe starting from 2023 paper and going back just to understand this. Here is another paper. This is a rod pumping predictive maintenance, where about 36,000 cars that were properly labeled by the experts uh, to identify about, and these were 300 beam pump wells from Bahrain, and there were several conditions that were identified by the expert. And this algorithm was developed using machine learning to, so that when a new card comes in, it immediately classifies that card. Depending upon the card, it predicts what is the happening downhole with the pump. So that's another interesting. But this is continuing on. Very recently, in just March 2024, Devon and some software partners published in JPT that how they are doing automatic bottom hole pressure calculations. Here is use case that if you have wellhead pressure and few wells with the downhole pressures, then how you can develop a machine learning model that can give you bottom hole pressure calculations, for which we traditionally have relied on software packages that cannot unfortunately be directly plugged into a real-time data stream. So that is where they did for about 5,000 wells. Another another paper talks about artificial neural network based discharge pressure prediction. So especially in case of ESPs, if you do not have discharge, both of them are similar problems in my mind, but they have tackled probably differently. Okay. Now, if we continue along, there are some more articles in JPT where people talk about how they are using computer vision, edge computing, generative AI, large language models, etc., etc. Don't let this terminology scare you away from it, because this is going to be the way of life for us. So better we embrace it. But everything, regardless of sophistication of this technology, and I'll repeat it, everything starts with the data, right? Now, Adnoc claims that using such AI software, they are unlocking $500 million value. So there are some practical business proven use cases that people are talking about. So it is imperative that we take care of our production data, which is a must for enabling this digital transformation. So we need to all think collectively in what ways will we contribute to ensuring sufficiency, quality, either we are data generator, custodian, or a data consumer. What is our recipe for making use of real-time data sets? Infuse real-time data stream with legacy offline physics-based approaches. Production team needs to understand and embrace emerging data science paradigms. Don't shy away from cloud computing, edge computing, Python, neural network, LLM, right? ChatGPT, Gemini, they are fantastic too. Of course, we can always point out some laughable use cases there also, but you can start with some prototype code very quickly. So learn how to prompt. And data scientists, we will be working with them. They need to incorporate our knowledge, our field values in order to develop reliable, explainable models that deliver business value. With that, I will conclude my presentation. It's about 45 minutes, so we have some time. Susan, please ask me questions.
Absolutely. I want to remind our audience that you are muted, but you can certainly ask questions using the GoToWebinar question feature, and you will be anonymous. And I want to thank everybody for attending today's webinar. Later today, you'll receive a link to a recording of today's webinar, an evaluation form, and a link to register for data analytics, workflows for artificial lift, production and facility engineers, which is scheduled for October 7th in Houston, Texas. And so, Rajan, you mentioned that although we've had fiber optics for decades, it's recently getting some traction. Why do you think that is, and what's the future for fiber optics?
I think I made that statement, but that is true for even traditional quartz-based gauges or other. I mean, they are becoming more. The primary reason why fiber optics is not adopted as widespread, the cost, because you're looking at easily 3 to 500,000, and my numbers may be somewhat old, right? So fiber optics has been always used in very, very high volume, very valuable wells like subsea or offshore. Uh, but now what I'm seeing is that with unconventional, people have started using fiber optics more for like identifying the completion related issues. But once the completion is done, then still we can continue, it will continue to send the data out. The second challenge, and I think it is more challenge, a bigger challenge, is non-availability of tools that can handle the large volume of data. I still remember a few years ago, I was working with one of the largest companies in the planet in oil and gas. And what I was shocked to find is that even they were unable to get all the fiber optic sense data from the field to their data center. They were still using SnickerNet because you're looking at 1 terabyte of data coming at you in one day when you look at the DAS data, right? DTS may be more manageable. So most of the time, the data is like very flaccid. There is nothing exciting going on. Once in a while, you're looking for that needle in the haystack. So not having a faster data processing mechanisms in place, data management mechanism in place has been the barrier. Now, talking about the opportunities, I'll continue to see that we'll not be investing as much into this, but we meaning the operators will invest in it, but only when the tools are available, when the reservoir community can get value out of that.
And talk more about the future of edge computing. Where do you see that going, particularly with artificial lift applications?
Yes, edge computing, it has started with lots of promise, but like any new thing, I guess that fruit is somewhat withering on the vine, in my opinion. The same way, if you go back in the history when the controllers were being introduced, I still remember talking to people about putting in Broadcom controller, and year was 2007-8, and people were asking me, why would I do that? Right? And the challenge was not only money, but okay, do I have sufficient manpower to manage this? Coming back to edge computing per se, I see much faster adoption, but again, the challenge is the same. these are sophisticated computers. You require slightly different workforce to handle it. What the edge computing or edge computer selling companies are doing is that remote management tools. The second challenge with edge computing is the applications. We still do not have as many applications. As I say during the presentation, there are machine learning AI models that you can deploy. But do we have even the back-end infrastructure to develop those models, to maintain those models, to track whether the model has gone out of calibration and it needs to be replaced and such? So those are the challenges that edge computing faces.
And you also mentioned the opportunity to use large language models. How do you see that evolving in the future?
Oh, that I think about 6 months ago, everybody was saying that large language model will eat everything else, right? But it was more of a hype. There are other approaches that will. So large language models, from my personal experience, I see. I already mentioned one application that I use almost on daily basis. Whenever I'm doing any Python coding, I rely on GitHub Copilot. There are a few others out there, right? So, and that is based on the large language model that was trained on the GitHub dataset. So earlier, when I was doing this work, I would go out and look into the Stack Exchange or quite a few other websites just to see how somebody has solved that problem, right? With large language models, I can see the same thing I can do, like I can quickly research few things. Now, you have to be careful because large language models have been also trained with data, remember? And how good that data set was. So you have to always go back. So oftentimes I use two or three of them. But going back to the question, large language models can be used in quite a few things. And there are quite a few things happening. It's like that duck where you cannot see a whole lot of things going on the surface. And we are seeing the application of large language model in the consumer space. In the business space, people are still taking, I would say, baby steps. And some companies that I have seen personally, I have worked with, are really making some interesting bets on them.
I really like how you expanded the sequence of surveillance, analysis, optimization, and added innovation to that traditional sequence. And where do you see the innovation evolving in the future? You mentioned AI and machine learning. What opportunities are there for innovation on the tool side? Or are there other things that you can see that could be improved?
Um, I think even though that diagram was presented as a sequence, in my mind, it is more like a closed loop, meaning you move forward and then you come back and fix something in the previous step. So it is not that the train is going to move in the same direction. So as we go forward, let's say we come back to the analysis part, right, from the surveillance. And then we realize that this analysis is indicating something that I need to get some more data. I have to go and fix my surveillance system. Similarly, when I go to the next real-time control, I realize that something else needs to happen. And in that sense, this is not only going to move forward. Now, where do I see this thing happening or going is there are many computations or many decision-making processes that are still being performed using a uh, limited sets of simulations, if you will, right? So whether you call it machine learning, AI, or whatever, tomorrow we'll have some quantum computing capabilities, right? What is going to happen is that we will explore much broader universe of possibilities. Right now, we might be coming up with an answer which is suboptimal. It is not a truly optimum solution. So I see us coming back and exploring much deeper questions. And so that is one way to answer that. Another way is, as I already mentioned, lots of activities which could be boring activity can be automated away. People are spending lots of, there's a lot of attention on what is called automated agents, right? So whereby right now our workflow involves doing step one, then step two, then step three. So why you cannot have three agents that can perform each of these steps and then they collaborate with it? That is another area where I see some interest emerging.
So working
But
in
again,
parallel rather than in series.
that is one way of looking at it. And not only working in parallel, but doing some deeper dive into some of these issues. That is how I see it. Another way to look at it is that there may be lots of tedious things that, like what Excel brought to the table when we started using it, is lots of macros did some computations automatically. Something similar is going to happen, that I do not have to wait for it. And we are already doing it in consumer space. If you think about it, what used to be, like, for example, in a little bit, I'm going to fly, right? And what used to be the workflow before? I mean, I would be high strung a day before. What is going now? Everything is coming on my mobile and I know where I'm going, what I'm doing, etc. The same thing needs to happen in our workspace. You reminded me of somebody. I was in one of the OTCs, maybe I think 2017 timeframe or so, 7 years ago, and one of the Middle Eastern producers, large producer, CEO, he just was asking me that, Rajan, I came here from my country, and in that aircraft, there's something called fly-by-wire. When are we going to have my wells flying by wire? Okay, so so that is the vision that people have. I'm sure we'll be stumbling a lot along the way. We
That's
are
great.
already. Yeah.
So we'll take our tips from journey management and we'll apply it to our wells management.
Yeah.
And you mentioned the challenges with unstructured data, how it's difficult to vectorize. So where do you see that evolving in the future?
I think increasingly we will have X source data management. So, for example, and this is a fantastic example of large language model usage, right? So we can train large language model or neural linguistic programming NLP based models to basically go through hundreds of thousands of email on daily basis, because those emails are saved on the server, right? And we can extract all the information, not somebody's baby's pictures, but what I'm talking about is, okay, on this well, what happened when? And then behind the scene, all of that information can be fluxed in a nice way so that tomorrow morning's meeting, before going to that tomorrow morning's meeting, I have all of that. That Joe said this, Jane said this, and 1 month ago, Jill did this, right? Right now, think about it, how much of time we are spending just putting it together for these production meetings or daily meetings or weekly meetings or whatever. So that is just one example I can give for the not only large language model, but some AI-based approaches. And I think the this data sets, we know now that when we start typing some text on your phone, the predictive text starts doing things, right? So if you train some of these large language models, then it will immediately figure out that, okay, in this well, this activity happened, meaning the next activity should be this. So that is where, and there are some vision-based approaches that people can use to extract some of this untractable data. And people are doing it already, by the way. I think, do we have time? I can expand a little bit on that. So I pointed out that there are some analog gauges out there in the field. In one application that I saw, and you might know about this, is that a company, they have all hydraulics-based infrastructure offshore. It's a brownfield. So they are not going to invest a whole lot, and there is not space even to put all the new sensing mechanism. So all they did was they just put some cameras that is facing their hydraulic panel, a couple of cameras, and they are relaying in real time the video, and their onshore data center is performing vision based, the same technology that your Tesla or any other car is using to detect whether it's a pedestrian or bicyclist or an animal on the road. The same way, it analyzes the gauge data to figure out whether you are in the red zone, green zone, or something needs to be changed. So there
Very
are,
exciting.
yeah.
Well, thanks to everybody for attending today's webinar. Later today, you'll receive a link to the recording of the webinar, an evaluation form, and a link to register for a data analytics workflow for artificial lift, production, and facility engineers, which is scheduled for October 7th in Houston, Texas. Thanks for joining us today. Goodbye.